Okay, so today we'll quickly do circular motion and then the rigid body and the concept of center of mass and moment of inertia. Okay, so so let us start with circular motion. Okay, some important things in circular motion. So uh, so 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 if it covers angle theta, okay, and if some point is moving in circular motion, okay, and it goes from this point to this point theta, okay, then your angular velocity, we write angular velocity as, like say, the initial angle is theta 1, the final angle is theta 2, so theta 2 minus theta 1 divided by t2 minus t1, this is your angular velocity, okay. So this is like del theta by del t, right?
Yeah.
So when it becomes like infinitesimal, then that will become the instantaneous velocity, which will again be same as d theta by dt. This is instantaneous angular velocity. Okay. Then similarly, this is velocity. Acceleration is written as alpha. Okay. So that also we write it as omega 2 minus omega 1. Like in linear, this is angular acceleration. In linear, let us say linear. Okay. So linear, you have the velocity. This is linear velocity. You write it as v. Okay. That is nothing but your distance, s2 minus s1 divided by t2 minus t1.
ds
right?
by dt.
So that is nothing but your ds by dt. So same thing. So that is, and then your acceleration. So acceleration is nothing but your v2 minus v1 divided by t2 minus t1. That otherwise can be written as dv by dt. Okay. So here it is omega 2 minus omega 1 by t2 minus t1. Okay. So this again is your, can be written as d omega by dt. Okay. So linear acceleration is rate of change of velocity. Angular acceleration is rate of change of angular velocity. Okay. So then there is, yeah. Then there is this. So this d omega by dt. Okay. This otherwise can be written as d omega by d theta into d theta by dt. That is the chain rule. Okay.
Yeah.
So that is again d theta by dt is nothing but your omega. Okay. So omega into d omega by d theta. This also you can write. Okay. Then there is a relationship between speed and angular velocity. Okay. So your speed, the velocity and angular velocity. Okay. Velocity and angular velocity, there is a relationship. So we are not deriving it now. Um, so just remember then this V is equal to R into omega. Okay. Similarly, this A is equal to R square omega. This thing, sorry, omega square R.
Omega square.
Omega square R.
For maximum velocity.
So omega R and omega square R. Okay. So so this is the relationship between the linear velocity and the angular velocity. Okay, and B is equal to r omega, A is equal to r omega square. Okay. So this thing, so you know na, that centripetal force or centrifugal force, okay?
Yeah.
Fc is equal to mr omega square, okay? So mr omega square. So this you know because this is acceleration. So this is linear acceleration. This is not angular acceleration. So this formula you have to remember that v is equal to r omega and acceleration is equal to
Omega square.
omega square r. Okay. So actually, how you get it? Because there is a relationship between this ds and d theta. Okay, so d theta is angle and ds is this.
Yeah.
So you know theta is equal to L by R. Okay.
Yes.
Okay. So your L is equal to R theta. Okay. So in this case, this ds is equal to R d theta.
Okay. Yeah.
So if you write it as r d theta by dt, okay, so this will become your r omega. Okay, the same thing for acceleration also it will become r omega square. Okay, so from this relationship theta is equal to L by R, this is being derived, and you have to remember that v is equal to r omega and a is equal to
Omega
r
square.
omega square. So there is something related to circular motion that is kind of suppose you have a curve like this. Okay, so your vehicle is moving on a curve like this. Okay, so when you have a curve like this and let us say you have a car. Okay, so you have the car. Okay, so when it is moving, let us say this is your center. Okay, so let us say this is my center. Okay, and let us say this is my angle. This is my angle theta. Okay, this is normal to the surface of the car. Okay, if that is the case, then what will happen? This car will have its own weight. Okay, so that weight will be mg acting like this. Okay.
Yeah.
Okay, so this mg and this will make a angle theta here.
Yeah.
Okay, so it will have a mg cos theta in this direction.
Yes.
So mg cos theta in this vertical direction. So the reaction on the bridge. So what will happen? This component, whatever is the component, your reaction will be balancing that. Okay.
Yeah.
Not only that, it will balancing the centrifugal force also.
Also.
There will be two things here. So this is your car. Okay. So on this car, you will have what will be the reaction on this car actually. That we want to find out. Okay. So you have the mass. So this mg. So because of this component, it will be mg cos theta. That we have got. Okay.
Yeah.
Plus a centrifugal force acting on it, that is mr omega square.
Omega square.
Okay, so when a car is moving on a concave surface like this,
Along with mg cos theta, mr omega square.
so r on this car when it moved on a concave surface is mg cos theta plus
mr omega square.
omega r omega square. Okay, Just remember omega square. R remains constant, just omega and omega square. So for acceleration it is omega square. Okay. So that is when a car is going on a concave surface. When it is going on a convex surface, okay, so this is the convex surface, so it will be opposite. So instead of getting added, it will
Get
just
subtracted.
get subtracted. So this is my
Like
car.
banking only.
Banking
Also it will get subtracted.
Yeah.
in convex.
So this is my car, and the new reaction will be R is equal to
mg cos theta minus mr omega square.
mg cos theta minus mr omega square. Okay. So this is for car moving on a convex surface. Okay. So this is the car moving on a convex surface. So you can see in a convex surface, then it will be reduction. Okay. It will be reduction. So these two things are important. Okay. Okay. Then there will be something related to skidding of vehicle on a level road. Okay. So on a level road, if you are going, and suppose you have a road, but it's a circular in nature. So you have a road. You have a road, but it is circular in nature, and let us say it is radius is r. Okay. Let us say the radius is r. This is a level road. Okay, that is concave convex, but this is a level road. So to avoid skidding, the v shape, okay, shape velocity, v shape. If it is a level road, will be square root mu g r. Okay.
Yeah.
Okay. So why it will be? Because what happens? Your mv square. Okay. So actually there will be a frictional force. What is happening here? There is a centripetal force and there is a frictional force which will be resisting it. So this will be the frictional force, let us say. Like say mu into r will be your frictional force.
Yeah.
Right?
Yeah.
And you will have a centrifugal force which is mr omega square. Okay.
Yeah.
So r is nothing but your mg.
Yes.
You are not matching here.
Resultant
Okay.
mg.
So mu mg is equal to mr omega square.
Omega
right?
square.
So your mm cancels. Okay. So okay. So it is mv square by r, you can write, right? mv square by r, right?
Instead of in terms of velocity.
In terms of velocity. mv square by r. So mm cancels. So v square is
Equal
square
to
root
root
of
mu gr.
mu gr. So to ensure that when you are moving on a circular road, to ensure that you don't skid, if your coefficient of friction is more, then only you will not skid. So your v shape means you should not exceed this speed. So if you know your coefficient of friction, okay,
You can find out what
and
is
you
that.
know your radius, that means more is the radius, more it is. But if the radius is less, that means see.
You'll have less space to
so,
skid
see,
around.
if your radius, so a straight road has a infinite radius.
Yeah.
Okay, but the more so yes, this road, but this road will have lesser radius as compared to this.
Yeah.
Okay, so if radius is less, this means if it is very curvy, like in you might have seen in when the road is very curvy, you have to go at very less speed.
Yeah.
That you have to maintain very less speed.
Yeah.
If it is straight, you can
Go
go
fast.
at higher speed. If it is very curvy, you have to go at very less
Yes.
speed. So that's why that is called v shape. Okay, shape velocity. Just you have to remember is square root mu g r. Okay, so that's how we derive it. Okay.
Yeah.
So and that bending of a cyclist we have already derived.
Yeah.
That also you have to remember. Like a cyclist is going, so he have to bend a bit. Okay.
Yeah.
To overcome that, so that there will be a component of his this thing which will overcome the centripetal force.
Yeah.
So that bending angle is tan theta by tan theta is equal to v square by rg. Okay. So that also you have to remember.
Yeah.
So these formulas, you just have to remember these formulas. We had derived it once, so
Yeah.
it will take lot of time if we derive it again.
Yeah.
So these are the formulas you should remember. Okay. So this is one formula, this is another formula, and then this is another formula, and then this is another formula. Okay. So these are some of the formulas you should remember, and these formulas also. Okay. These are related to circular motion. And okay, so these are some of the important things related to circular motion. Okay, you understood?
Yeah.
And there are some more formulas related to circular motion, which are like yeah, that you know, like V is equal to U plus AT. Okay, so that you know already. So here equivalent is omega equal to omega 0 plus alpha t.
Yeah.
Because this is your angular acceleration. Okay. Similarly, S is equal to ut plus half at square. That you know. Okay. So that instead of S here it will become theta. Theta is equal to u instead of u
Omega
it will become
naught.
omega 0. Right?
Yeah.
Omega 0 t plus half
Alpha t.
alpha t square. Okay. Theta is equal to omega 0 to the on the, and then another formula, major formula you know, b square is equal to u square plus 2s. So in place of that it is omega square is equal to omega 0 square plus 2 alpha into theta. Right? So these are some of the major formulas. Okay, from linear to circular. Okay, so now we have covered circular motion. Okay, so you take a picture, then we will go to the next chapter. Clear? So,
Yeah.
any difficulty in
No.
understanding this?
This one.
If you just see this much of snapshot and remember, that also will help you to solve one or two minutes. Okay. So this is about circular motion. You have taken picture, na?
Yeah. It's out.
Okay.